show this apart from the Keon, the B meson is another. And recently saya tengok dalam internet ada lagi satu satu jenis meson. Tak silap saya D meson. So you have the Keon, B meson, and I think now is the D meson. Mengapa tidak dipanggil Beon? Nanti jadi biol pula. Yang ni Deon pula. Jadi susah nak sebut. Biarkanlah. So they put violating fish ni delta katakan. So let sine is just SI dan cos dipanggil CI. Then they propose you have C1 minus S1, C3 minus S1, S3. Okay? And then you have S1, C2, C1, C2, C2, C3 minus S2, S3, E, I delta. And then you have C1, C2, S3 plus S2, C3, E, I delta. S1, S2 macam kod pula C1, S2, C3 plus C2, S3, E, I delta dan C1, S2, S3 minus C2, C3, E, I delta. Itu adalah yang dituliskan oleh Kobayashi Maskawa. Now, that is what you. So this is the parameterization by Kobayashi Maskawa. Of course, you can rewrite that in terms of the apa ni yang the CK metric yang saya tuliskan tadi, 3x3 matrix. You can rewrite that. See, this is just a parameterization, but that is also called standard parameterization. Kenapa kita nak standard? Because we want for some application the standard parameterization is written in terms of triangle. This uses three what you call Euler angles rather than Cabibbo angle, which is theta 1, 2, theta 2, 3, and theta 1, 3, and one CP violating phase delta 1, 3. And the coupling between the quark generation I and J vanishes if theta ij equal 0. So the nice thing about this parameterization, it will show coupling between quark generation I J vanishes if theta ij equals 0. Or in other words, if it is small, it is vanishing anyway. Now, cosine and sine are denoted Cij. and Sij. So the cosine become Cij, and the sine is denoted as Sij. And theta 1, 2 is the so-called original Cabibbo angle. I mean, of course, there are 3 by 3, so there are 9 possible angle actually, isn't it? So, and they, the nice thing about this parametrization is that you can almost diagonalize. I'm not saying you can diagonalize, but you can almost diagonalize. So, let me write first C12, C13, S12, C13, and S13 E minus I delta 13. So this is a 3 by 3 matrix. I mean, this is just what you call parametrization. Minus S12 C23 minus C12 S23 S13 e to the I delta 13. Then you have C12 C23 minus S12 S23 S13 e I delta 13. And here you have S23 C13. And here S12 S23 minus C12 C23 S13 e I delta 13 minus C12 S23 minus S12 C23 S13 e I delta 13. Nobody can remember this number. C23 C13. And actually you can split this into 3, as I said, almost diagonal, but not necessarily. So this is 1, 0, 0, 0, C23, S23, 0 minus S23, C23. Almost diagonal, but not quite. Okay? And then you have C13, 0, S13E minus I delta 13. And then you have 0, 1, 0 minus S13E I delta 1, 2. Delta 13. And then 0, C13. C12, S12, 0 minus S12, C12, 0, 0, 0, 1. Actually, this splitting into 3 has some meaning, but I don't want to go, into the discussion of why you split, or you can write it into 3 by 3. This theta 1, 2 is about 13.04 degree. Theta 1, 3 is about 0.201 degree. Theta 2, 3 is about 2.38 degree. And delta 1, 3 is about 1.2 radian. Now that is an attempt. Instead of writing the standard parameterization, pening pala, so many C and S, nobody can remember. So people use the so-called Wolfenstein parameterization. This is one of the best way to understand, to make the CKM simple. So this use only for parameter lambda, A, rho, eta. The nice thing about this lambda, A, rho, and eta, they are all about of the order of value of 1. So easy to remember. So all these values are about 1. And they are related with the standard one there. So the lambda is actually S12. A lambda square is actually S23. And A lambda cube rho minus I eta I delta. And this parameterization is actually can be written as 1 minus lambda square over 2 lambda A lambda cube rho minus I eta. And then you have minus lambda 1 minus lambda square over 2 A lambda square A lambda cube 1 minus rho minus I eta minus A lambda square 1. So this is easier to remember. And the CP violating phase is the rho minus I eta. Is given by rho minus I eta. Oh, the other thing why Kobayashi Masukawa got Nobel Prize is because they actually predicted the existence of the third family. Okay, as you can see this S1, 2, 3, C1, 2, 3. That's why, because the neutrino they don't interact with anything, so they will travel, then only they start changing. Yeah. Neutrino ni macam orang Melayu lah. Kalau dia travel duduk Sweden, lepas tu duduk Sweden 10 tahun, dia balik dia dah jadi orang Sweden dah. Bukan jadi orang Melayu lagi. Kalau dia duduk England, dia jalan-jalan dia sampai negeri Arab, dia balik dia pakai jubah lah, dia tak pakai baju Melayu lagi lah. Neutrino ni macam lebih kurang macam orang Melayu lah. Dan dia tak berinteraksi sangat. Neutrino ni memang dia tak berinteraksi, tapi dia tahu pula nak berubah. We don't call it like that. The quark we call quark mixing. The neutrino we call it oscillation. As I said, the neutrino need to travel. Since they don't interact with anything, lepas dia travel baru dia berubah diri dia. Ibnu Battuta dia satu dunia dia pergi, tapi dia balik masih Arab lagi. Ya tak? Orang Melayu aja duduk Sweden jadi orang Swedish, duduk England jadi orang Masaleh. Itu yang kurang bagus tentang orang Melayu ni. So I think we take a break for 5 minutes before we go to neutrino oscillation.